Hey physics friends, Mr. Collier here. I want to show you a sample problem about conservation of energy. So here we have a 2 kilogram ball that's thrown up in the air at 4 meters per second. We now, using energy, can analyze how high it's going to go and several other things. So the first part of this question, because I kind of take it in baby steps, is how much kinetic energy does it start with? So that's as simple as kinetic energy equals 1/2 mv squared. We know the mass is 2 kilograms, and we know that the starting velocity is 4 meters per second, and we're going to square that. So 1/2 of 2 is 1, 4 squared is 16. That's going to be 16 joules of energy that it starts with. The next thing we ask is what's going on at the apex. So this is really something that will often not be written in the problem. It's kind of there for you to figure out. And the idea is that if you've thrown a ball into the air with some initial speed, then you've given it some initial amount of energy. And as it travels through the air, that kinetic energy is turning into potential energy. And so at its apex, when it briefly stops moving, it'll have 0 joules of kinetic energy. And that means that all of its energy has been turned into potential energy, gravitational potential. And so since energy is conserved, in this particular example, it would be 16 joules of potential energy. So now we can use that value, knowing that PE at the apex is equal to 16 joules, and knowing that that's equal to mass times gravity times height. Now we can solve for how high in the air does it go. So we get 16 joules equals 2 kilograms times 9.8 meters per second squared times the height. And that height will be its max height. And when you solve this, you're going to get that the height is equal to 0.82 meters above the ground. So that's it. That's your conservation of energy. As an object goes up into the air, kinetic turns to potential. If it were to fall back down, the opposite will be true. Let me know if you have any questions. Thanks.